Okay, so this is page 26, lesson E8, the second derivative test. Okay, so guys, the second derivative test you actually can't always use. It's for local extrema. Okay, so for local extrema. All right, and you'll see why in a moment why it doesn't always work. Okay, so local max. Let's draw two situations. All right, so here's one where the local max is like right up there. And so it's going to be we'll call it a smooth local max if M tan is equal to 0. Okay, so it would be like a case like this. But then you may have a local max that is not smooth. Let's say that it looks like this. All right. So in a case like this, M tan is undefined. Okay, you can't draw a tangent line. So in this case, the second derivative test would work, and in this case, it would not. Okay. Local min, similar situations. You could have like a smooth local min, in which case you will be able to use the second derivative test, or you could have like a local min that looks like that, where you can't use the second derivative test. So maybe we should write that down. Okay, so second derivative test will work for those, and on the other side it won't work. Second derivative test won't work. And I mean, one way of looking at it, guys, is if the first derivative doesn't even exist there, if it's undefined, then you can't even take the second derivative. So it wouldn't be helping you. Wait, I think it works like that. I think it works like that. Okay, all right, let me just continue. So calculus tests for local relative extrema. Okay, so first derivative tests for local extrema. That's when you do the number line. This will always work. It will not be inconclusive. The second derivative test, which I'll show you shortly, you don't need a number line, but it doesn't always work. Okay, this is the way we have been doing it. You'll find the critical numbers, and you put them on a number line, and you look for a sign change. Okay, that's described here and here. But then over here, I am describing what's called the second derivative test. Okay, for a local max. If f prime of c is 0 and f double prime of c is less than 0, then f has a local max at x equals c. Okay. So guys, this is telling you that you have a horizontal tangent there, and then this is telling you about concavity. So if you've got a horizontal tangent at a spot where the graph is also concave down, then you're going to have something that looks like this. So you will have this like a smooth local max situation. Okay, now a local min goes like this. So if f prime of c is equal to 0, so again, horizontal tangent, and f double prime of c is greater than 0, then f has a local min at x equals c. So f double prime of c being, whoa, sorry. I was watching something on my phone earlier. F double prime of c is greater than 0. This allows you to conclude concave up. So you know that f is looking something like that. All right, so basically that's how the second derivative test for extrema works, is you're allowed to use the second derivative to conclude something about the concavity, and then if you have a horizontal tangent in addition to that, that's where you make your conclusion. Okay, so guys, page 27. We're gonna cross off parts A and B, and we're just gonna jump right to part C, and we're gonna add this little piece of information here. Okay, So for the problem below, f is a twice differentiable function. Selected values are shown in the table below. Okay, state any local maximums or minimums that may be concluded from the table. So guys, we can't do a number line from this. Okay, not enough information. But what we can do is look at the second derivative along with the first derivative, and then we may conclude from that some local extrema. Okay, so we're looking for f prime to be 0. All right, so that is happening here and here. And then we also need for f double prime to be a positive or a negative number. F double prime being 0 actually wouldn't help you. You wouldn't be able to use the second derivative test. Okay, so here we've got our second derivative values. All right, and I'll jump like right to it. So my x value here is 8, and I'm getting an f prime of 0. So f prime of 8 is equal to 0. F double prime of 8. Now they're telling us that f double prime of 8 is negative 1, but I don't even need the specific value. I just need to know whether it is a positive or negative number. So this is less than 0. Okay, so guys, what this allows you to conclude, I'll do like 2 arrows here. All right, so this is allowing me to conclude that I've got this picture. Right, this is concave down. Right, so I've got like this type of picture going on. All right, that'd be M tan. All right, so let's say that this is F. So this point right here, up here, that point is 8, 4. Okay, the picture is optional. And then through the picture, after the picture, I'll do another little arrow. Here's my conclusion. Will be that local max. Okay, now I'm finding the local max, so the answer is the y value. F of 8 equals 4. Okay, now let's do the other one. So f prime of 20 is 0. Okay, so horizontal tangent. F double prime of 20 is 4, which is a positive number. So horizontal tangent and concave up. Horizontal tangent, maybe for our notes we should say that. So horizontal tangent, and here we had concave down. Here we have a horizontal tangent and concave up. So that is allowing me to draw this picture. And if you don't want to draw it, you could just think of it in your head. All right, and then this point here is 20 comma negative 5. Okay, so we've got a local min. F of 20 is negative 5. All right, guys, we're almost done. All right, so that's the second derivative test being used on a table of values. Now let's do this. So identify the values at which f of x equals this has local maximums and minimums. Use the second derivative test where applicable. Okay, so if they weren't asking us to use the second derivative test, we would just do what we've been doing. Take the first derivative, get its zeros, put them on a number line, look for sign changes. Okay, now that we still could do that, but they asked us to use the second derivative test, so let's do that. Let's try that. And then if it won't work, because sometimes it doesn't work, and you may see that here, then we'll have to revert back to a number line. Okay. Oh, by the way, when we are finished, we'll flip to the next page and compare our work to the alternative work shown. Okay. So anyway, I've got to take the first and second derivatives. Okay, so the first derivative, 15x to the 4 minus 16x squared. Okay. And I'll need the second derivative also. 60x third minus 120x. Okay. All right, so now let me factor this because I'm going to need the critical numbers. X squared. Okay. Whoops. Alrighty, so f prime is 0. Or I'll come back. But you could see the critical numbers, guys. 0, -2, and +2. So those are the numbers. Maybe I should write that. The critical numbers are x equals 0, x equals 2, x equals -2. Okay, so right here, all of these numbers satisfy the first part of the second derivative test. F prime is 0, okay? So I know that I have horizontal tangents at these values. That does not, however, mean that they correspond to a local extrema. Okay, for that we need either to check a number line or the second derivative. So let's try the second derivative because they're asking us to. And when I do the second derivative test, guys, when I plug these into the second derivative, I don't care about the exact number. I just care about positive or negative outcomes. So it will be helpful to factor this because then we could see faster whether we get a positive or negative outcome of a product. All right, so let me factor. So I'm taking out 60x and then left x squared minus 2. Okay, so that's all factored and ready to go. All right, so I'm going to plug these into the second derivative. So f double prime of 0. When I plug a 0 in here, I get 0. All right, guys, what does that mean? Can't use second derivative test here. Okay, so we're going to have to go to a number line, but let me do the other ones. Okay, so double prime of, I'll do positive 2 first, and I only care about a positive or negative outcome, so let me look. Positive, 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 greater than 0. Okay, so my concavity at 2 on F is up, concave up. Okay, now let's do double prime -2. So I only care about the sign, negative, negative, negative. That is a negative outcome. Okay. All right, guys. So, all right. So these I'm going to be able to use the second derivative test on. All right. My concavity here is concave up, so I'll have a -2. Concave down here, so I'll have a max at -2. Now let's see what's happening at 0. So for this, I have to go back over here to an f prime number line. Now, even though I'm not doing a sign test at -2 and 2 on this number line, I still want to put them there because when I take my testing values, I don't want to choose like ones that go beyond -2 and 2. That would mess everything up. Okay, so I'm choosing -1 and 1. I'm plugging into the first derivative, and I get a positive, positive, negative, negative outcome. Okay, plug in a 1. Positive, positive, negative, another negative outcome. Guys, no sign change. No SC. I'll say no SC for no sign change. So yeah, 0, even though there's a horizontal tangent there, I'm not seeing a sign change on f prime, so that does not correspond to any type of extrema. All right. Okay, so let me just put together what I've got here. So we've got f prime of 2 is 0. F double prime of 2 is greater than 0. All right, so what do we have? We have, so concave up, so min at x equals 2. Guys, notice I'm not finding the y values because of how they asked the question. Identify the values at which this has maxes and mins. We're not finding the maxes and mins, we're finding the values at which they occur. Okay, min at x equals 2. All right, so now f prime of negative 2, f double prime of negative 2, 0, less than 0. So that means concave down. Max. And guys, if you can't see this clearly in your head, then draw a picture. Draw like a little picture just like I did here. I skipped that step. Okay, now we're going to flip to the next page and compare our work to the alternative work shown. Guys, this is just me doing just the normal thing that we've been doing. F prime number line, I'm looking at the sign changes. So I saw a positive to negative sign change here, indicating a max. And I saw a negative to positive sign change there, indicating a min. Okay, there it is, guys.